The next figure we are about to see is a prism. Now look at this prism. This is called a triangular prism because the base is triangle. This base could be also different. Now triangular prism has a triangle at the base and it has a triangle on the top. So we have two triangles here and we look at these figures. So here we have three rectangles. So one rectangle here, second here and third here. So this is the prism here. So here if we have to count the number of faces, we have 1, 2, 3 faces here, 4 and 5 faces here, and these are the edges. So we have 1, 2, 3 edges on the sides, 4, 5, 6 here and 7, 8, 9. These are 9 edges and these are the vertices. So we have 3 vertices here and 3 vertices on the other side. So 6 vertices. So this is a prism and we call it a triangular prism because the base is triangular in nature. Then next we see some pyramids. Now this is a pyramid. Again this is a triangular pyramid. It is called a triangular pyramid because the base is triangular. Now this is triangle and we have 1, 2, 3 triangles tapering upwards. Now if you look at the number of faces of this pyramid, we have 1 face, that is the base here, and 3 on top. So 1 plus 3 becomes 4. If you look at the edges, we have 1, 2, 3 edges here and 3 edges below. So 3 plus 3, 6. And look at the vertices 1, 2, 3 and 4 vertices. So this is a triangular base and there are 3 triangles on top. So this is an example of a triangular pyramid. You can also have a square pyramid. This is an example of a square pyramid. Look at the base. The base is square and here you find that it is made up of 1, 2, 3, 4 triangles tapering upwards. So this is called a square pyramid. And in all these figures, if we find the number of faces, edges and vertices, there is a formula f minus e plus v is equal to 2. So all these figures should satisfy the Euler's formula, that is f minus e plus v is 2, where f stands for the number of faces, e stands for number of edges and v stands for number of vertices. Then we have another figure which is called a hemisphere. Now this is a hemisphere. It is half of a sphere. When we have two hemispheres, we join together two hemispheres, it becomes a complete sphere. It's like a football. So it's a 3-dimensional figure. It has no edges, faces or vertices because all are curved surfaces. If I break this exactly into 2 parts, then it becomes 2 hemispheres. So if the hemisphere is open, we say it is having curved surface area, and if it is closed, then we say it is total surface area. So a hemisphere or a sphere is not an example of a polyhedron. This is not a polyhedron because it doesn't have any vertex or any edges. So in hemispheres, we can find out the area and volume by using its formula. But Euler's formula cannot be verified because faces, edges and vertices are not existent in hemispheres or spheres.